In number 9, Carlos thinks he has discovered a new variation of monarch butterflies. So he collects 4 new butterflies and 4 traditional butterflies and measures their wingspan. And what happens is he finds that the difference between the means of the wingspans of his 4 new butterflies and 4 traditional butterflies was 0.5 centimeters. So the mean difference here is 0.5 centimeters. Okay, now what we want to do is we want to take a look at where 0.5 lies in this dot plot and see if it falls within the 95% confidence interval. Now keep in mind, anything within the mid 95%, okay, the mid 95%, may be due to chance. It could just be because of natural sampling variability. Whereas anything outside of it, anything over here or over here, is considered statistically significant. All right, so in order to do this, if you go back and read the problem, he wound up, there's 70 dots here, okay? He did 70 resamples. And so if we see where 0.5 lies, right here, let's count the dots. Let's count all the dots 0.5 and greater than it. So we have 1, 2, 3, 4, 5, 6, 7. So we can say that 7 out of the 70 total dots is 10% of our samples. So in order for something to be statistically significant, it needs to be outside of this middle 95% right here. It needs to be outside of that. Now, if the mid 95% is, let's say, right here, okay? If you take that extra 5% and divide it by 2, you'd have 2.5% over here and 2.5% over here. So really, in order for this 0.5 to be statistically significant, it needs to fall somewhere out here in the 2.5%. And it's not. It's all the way up here at 10%. So what we can write out here is that the mean difference discovered by Carlos was not of statistical significance. There is a 10% chance of values being as big or bigger than his observed value. So with a 95% confidence level, this difference is not within the outer 2.5%. It's within the middle 95%. So we could say it is not statistically significant. It could be due to natural sampling variability. All right, so number 10 is looking at finger tap rates with and without caffeine. So in part A, all they're really looking for here is they want you to find the mean of the taps per minute for the 2 groups, so between the caffeine group and the non-caffeine group. So you could do one of 2 things. I mean, there's 10 members in each group, so you could either add up these 10 numbers and divide by 10, or you can go into your calculator and you can plug in, under list 1, you can plug in these 10 numbers and go to var stats and let the calculator determine the mean for you, and you can do the same thing for the no caffeine group. Might as well do it both ways, that way it's kind of like a check for your answer. All right, so here's what we get for the mean for each group. So in part B, they just want you to determine the difference of the means of the taps per minute for the observed data. So the caffeine group minus the no caffeine group. And then they want you to explain its meaning in the context of the problem. So when you subtract the 2 means, you get the difference of the means to be 3.5. Okay, I'll show the work right here. So I wrote, this value indicates that the students who drank the coffee containing caffeine averaged 3.5 taps per minute more than the students who drank decaf coffee. Letter C is asking whether there is statistical significance in the difference of the means. So, all right, well, if we take a look, we know the difference of the means is 3.5. So figure if this is where 3 is, right, 3.2, 3.4, figure 3.5 is somewhere around here. So these 3 values are as big or bigger than 3.5. So if we take those 3 values and divide it by the total number of samples we have here, it says up here that we have 1,000 dots, okay, 1,000 samples. That gives us 0.003, which if you change that to a percent is less than 1%. It's 0.3 of a percent. Okay, so that's less than 1%. So since it's in our outer 2.5, right? We know these are our two outer 2.5%. Since it's not within the 95 percentile, we can say that there is a statistical significance here. Okay, so I wrote the mean difference was of statistical significance. There is less than a 1% chance of a value being as big or bigger than the observed value. Using a 95% confidence interval, this difference is within the outer 2.5%, so it is statistically significant. Number 11A wants us to decide what is the expected mean. Well, they tell you that 85% of young adults ages 16 to 21 use Twitter, so you expect the mean of the sampling distribution to be at that 85 percentile. So 85% would be the answer for this. Okay, now in part B, it says to use your results from A to find the standard error. So if we want to find the standard error or the standard deviation, we can use our formula that says we're just going to take the square root of P times Q and divide that by N. All right, well here our P is the expected mean of the sampling distribution, which was 0.85. That's what we got in part A. Q would just be 1 minus this value. So 1 minus 0.85 would be 0.15. And we're going to divide that by 100 because 100 randomly chosen young adults were used here. All right, so then just plug that in your calculator, and I wound up getting for this, I'm going to write 0.036. All right, so that's what we're getting for part B. Now part C says to describe the graph of the sampling distribution of the sample proportions. Well, the graph should just be approximately normal. Okay, letter D says if the sample size was increased to 5,000, how would this affect the sampling distribution of the sampling proportions? An increased sample size would not affect the mean, but what it does affect is the standard deviation. It would create a smaller standard deviation. Okay, so increased sample size decreases the standard deviation. It'll be less spread out. And also you could say the distribution will be taller and skinnier. So number 12 gives us a picture of this graph, and they tell us that the function can be written in this form, and they just want to know what's true about B. Well, this graph shows exponential decay, right? It's going down like this. And whenever there's exponential decay, this value of B has to be somewhere between 0 and 1. I mean, try it out. For example, in your calculator, if you went to y equals and plugged in, let's just replace that B with a 1/2 to the x power, you'll see a picture that looks something like this. Just keep in mind, if it's exponential growth, right, if your graph is going up, then this value of B right here is going to be greater than 1. Number 13 wants to know if a person from this poll is selected at random, what is the probability that the person is against the candidate given that the person is between the ages of 41 and 60? So since we're given that the person is between the ages of 41 and 60, we're looking at this right here. And if you were to add up the 20, the 40, and the 15, you would see that there'd be a total of 75 people. So if we want to find the probability that they're against the campaign, well, there's 40 people that are against the campaign given these 75 total people. So 40 over 75. Number 14 asks, what is the probability that the student is in the 11th grade given that the student is in 3 or more clubs? So we're given that the student is in 3 or more clubs, so we're really just looking at this column right here. Now, if you add up all of these numbers in this column, it's going to total out to be 68. Okay, so out of these 68 students, we want to find the probability that the student's in 11th grade. All right, well, there's 18 11th graders out of the total 68 students. So 18 out of 68. So number 15 can be done through a Venn diagram or a two-way table. All right, so if we do it through a two-way table, let's just read through and see what goes where. So it says a class of 40 students, so we'll put 40 in the total here, has 11 honor students. So if we go to honors and go over to total, we can put an 11 there, and 12 athletes. So if we go to our athletes and go down to the total, we can put a 12 right there. 3 of the honor students are also athletes. So in the box where honors and athletes intersect, let's just put a 3. All right, so that's what they give us. Actually, at this point, we can just fill in the table. So let's just start here. 3 plus 8 is going to give us 11. Or you could say 11 minus 3 is 8, so let's put an 8 here. All right, and then we can do 40 minus 11 is 29, so we'll put a 29 here. 40 minus 12 is 28, so we'll put a 28 there. And then 28 minus 8 is 20. And finally, 12 minus 3 is 9. All right, so our two-way table is filled out. So it says one student is chosen at random. Find the probability that this student is an athlete if it is known that the student is not an honor student. So if we go to our non-honor students, we're looking at these students right here. So there's a total of 29 of them, so that's going to be the denominator of our fraction. And if we want to, determine how many of them are athletes, it says right here that 9 of these students are athletes. So it's just going to be 9 out of 29. Right, if you wanted to do it through a Venn diagram as well, I'll just quickly do that. So we can make a Venn diagram, and we would have our honor students and our athletes. And when they tell us that there's a total of 40 students, we would put that on top. They told us that 11 of these students are honors, so we'll put an 11 on top of the honor circle, and 12 are athletes, so we'll put a 12 up here. All right, if 3 of the honor students are also athletes, so 3 are both. All right, so in order to find the missing numbers here, we can just do 11 minus 3 to give us 8 honor students that are not athletes. And then we can do 12 minus 3 to give us 9 athletes that are not honor students. And if you want to find the neither, you can just add these 3 numbers up, which they just add up to 20. And if you subtract that from the total, that means 20 are neither athletes nor honor students. So now, if we're looking at this, it says find the probability that the student is an athlete if it is known that the student is not an honor student. So if we look at the non-honor students, these are the honor students right here. There's 11 of them. So the non-honor students are anyone outside of the box. So these 9 and these 20. So altogether there's 29 non-honor students. So again, that'll be the denominator of our fraction. And out of those 29 students, these 9 right here are the ones that are athletes. So 9 out of 29.